Hello and welcome to another Reigate Maths video. This one focuses on the second year content for trigonometry, looking at reciprocal trig identities. So the key thing with these is you should already know that sine, cos and tan can be linked in these two ways. You did that in the first year, some of you may have done it at GCSE. So it stands to reason that cosec, cot, and sec can also be similarly related. It's not exactly the same. And that's something that a lot of students really find difficult, is they're happy remembering these two, but as soon as you put three more in the mix, it starts to get a little bit confusing because they're very similar but look very different. If you've watched the previous video on calculating using reciprocal trig functions, we've seen one of the trig identities already, and that's that cot theta is cos over sine, which should make sense because this is 1 over tan, so it's 1 over this fraction. But what about the other ones? So we're going to have a look at proving the two remaining trig identities for this type of thing. When we start looking at addition formulae and double angle formulae in another video, those will come back and we'll have some more trig identities there, but we'll get to those when we get to them. So let's have a look at the other two trig identities. The first one that we are going to prove is that sec squared theta is tan squared theta plus 1. So the two trig identities that we're going to look to prove both stem from this one here. This sine squared plus cos squared equals 1. Because don't forget, in every single proof, you have to start with a known fact. And we know that sine squared plus cos squared is 1. Okay? So we're trying to prove something involving tan squared. Now we know some trig identities with tan. We also know that sec is 1 over cos. So how can we change this function or this identity to get a sec and a tan without changing the value of it? We're going to divide everything by cos squared. We can see we have sine squared over cos squared, which is the tan squared we wanted. Cos squared over cos squared is 1, and 1 over cos squared is sec squared, which gets us that trig identity there. The other identity, that 1 plus cot squared is cosec squared, can be proved in a very, very similar way, just dividing by sine squared instead of dividing by cos squared, like so. You need to know these proofs. They could very easily be a nice quick 1 or 2 mark question in the exam. The way we use them is almost identical to the way you use the trig identities here from the first year. Because they're all very, very similar to each other, the style of question is always very, very similar. You just have to identify which trig identity to use. So this is the next example we're going to look at. Solve the equation 4 sec squared x minus 3 tan x minus 5 equals 0, giving all our answers to the nearest degree in the interval 0 to 360. So lots in there telling us to be working in degrees mode. So before we even start this question, make sure your calculator is in the correct mode. If you're super confident with this, then pause the video and have a go on your own, and then we'll go through it, bearing in mind that it works in very, very similar way to the questions you were doing last year. So, we know what we're starting with. We have our equation here. So we can look at this and go, okay, we have a mixture of trig functions. We need to change one of them into the other one. So we need to look at this equation and go, okay, can we deal with the sec squared to make it something involving tan, or can we deal with the tan something involving sec squared? It's the former of the two, because we know that sec squared x is 1 plus tan squared x. So that's the trig identity we're going to use. Once we've got that, it's a case of substituting it in, multiplying out the brackets, and simplifying. Now, sometimes for questions like this may well be the part A of the question for 1 mark. It'll be maybe show that this can be written in this way, to give you kind of that nice, oh, if you can't do this bit, you can still have a go at actually answering the question. Because from here, we just proceed as we would before. We have a quadratic equation in tan, so we factorize. And solve. Here, we use our calculators because this doesn't come out as a nice exact number. So, very simply, making sure we're in degrees, inverse tan of minus a quarter, we get minus 14. Now, obviously, this is outside the interval that we're going to be working in, but I'm going to write it down anyway, just to be safe. From there, we're just going to add 180 to it a couple of times, and round to the nearest degree each time. So this is 166 and 346. I'm going to tidy this up later, but I'll leave it like that for now. Tan theta or tan x equals 1 is a nice one to solve. We get 2 solutions. Now, because I left this negative one in here, I need to summarize all of my answers at the end to show I'm ignoring that one. And I like to put them in numerical order. You don't have to do this, but the examiner appreciates it, because the answers tend to be given in the mark scheme in numerical order, makes it easier for them to mark. And if you make the examiner happy, it makes it easier for them to give you marks. So, that's how you solve an equation involving reciprocal trig functions. It's exactly the same as last year, just with a couple of added steps on the front. Thank you for watching.